Introduce our speaker today. We have Susan Shaw presenting. This is on team-based variability reduction, an application of statistical engineering. This was originally presented at IQPC this year. Sorry, IQPC at the ASQ World Conference, and we wanted to follow up with a few of those presentations by webinar for people who maybe missed the talk at the conference or could not make it to the conference. So Susan's the president and owner of SOS Consulting. She has over 20 years of experience using engineering, statistical, and business process improvement methodologies in companies in the chemical, food, automotive, industrial supply, education, and printing industries. Before she was a consultant, she had a variety of positions with R.R. Donnelley, GE Lighting, DuPont, and Eastman Kodak. She's a senior member of ASQ and serves on the editorial board for ASQ's Six Sigma Forum and Quality Engineering magazine, as well as the ASQ Awards Committee and the ASQ Statistics Division LSR OTT Scholarship Board. She is a certified quality engineer by ASQ and a Six Sigma Master Black Belt. She has a BS in mathematics from the State University of New York at Fredonia, and a bachelor's, master's, and PhD in industrial engineering from Penn State University. So I'm now going to turn things over to Susan, and Susan, I'll go ahead and say it now, and I'll say it again at the end. Thanks a lot for repeating your talk for us via webinar.
Thank you, Joel. My pleasure. Thank you, everyone, for joining us this afternoon. I'd like to... Oh, my slides are not moving here. Start first with a couple of thanks. First, thank Ron Snee of Snee Associates for encouraging me to share this story the last couple of years, and to thank Gloria Zazu-Diaz and Riley Murray, who engaged me in this work initially in 1999, and Katie Weaver, who joined the team a couple years later and kept the rest of us all organized. The objectives for my presentation this afternoon are twofold. First, to show you how to systematically put data and basic problem-solving tools in the hands of the workforce and to generate improved and sustainable results over time. And then second, to provide a practical example of statistical engineering. The outline that I'll follow is first to define statistical engineering, and then to give you some background on the situation that existed that led to the development of this variation reduction methodology, then share the details of the roadmap and the tools that make up the methodology, talk about the other elements of the methodology, share some examples, lessons learned, and the benefits that were achieved, and close with some more, where you can find some more information as well as answer your questions. So first of all, what is statistical engineering? Roger Hoerl and Ron Snee in their 2010 Quality Progress article defined statistical engineering as the study of how best to use engineering statistical concepts, methods, and tools to integrate them with information technology and other relevant sciences to generate improved results. So keywords here is the integration and improved results. I hope you'll see that in this methodology that I'll share with you this afternoon. In a subsequent article, Roger and Ron also defined 5 aspects underlying statistical engineering, which I believe are also in this methodology. First, a system or strategy to guide the use of statistical tools. Second, the impact of statistical thinking and methods can be increased by integrating them together and enabling practitioners to deal with highly complex issues that cannot be addressed with just any one method or tool. And third, linking and sequencing the use of the tool speeds the learning of the approach and thereby the impact of the method. 4, embedding them into daily work institutionalizes their application. And I think most definitely you'll see that here. And then 5, viewing statistical thinking and methods from an engineering context provides a clear focus on problem solving to the benefit of humankind. So before we go into defining the variation methodology, given these two processes, process A and process B, which would you rather have? Think about it. Process A has wide swings in performance. So it's not very predictable, and that lack of predictability may result in high costs for labor and materials. It may also result in constant firefighting and difficulty maintaining any improvements that are made. Process B, on the other hand, has a much narrower swings in performance, so it's more predictable, and that predictability may result in lower costs for labor and materials, more consistent process output, more effective corrective action, and increased flexibility. So I hope you selected process B. It'll have a lot more benefits than process A. So next, some background that led to the development of this variation reduction methodology. It was a printing company with over 20 facilities in North America. They had begun a continuous improvement journey in the late 1990s, which included ISO 9000, some workplace organization using 5S, problem solving using basic quality tools, an employee engagement approach similar to GE's workout, and they'd also begun implementation of Six Sigma. The efforts were originally, however, very decentralized and dependent on local leadership at each facility. They've had a lack of standardization and stabilization in their processes, which limited the impact of each of these approaches. And as far as leadership was concerned, the results were not fast enough and they were not sustained. At the same time, they were also implementing a new ERP system, and for the first time had access to data from their equipment that they had not had before. As they were implementing these improvement methodologies, particularly Six Sigma, it was taking 9 to 12 months to finish projects. And in investigating what was going on, the leadership team found that green belts and black belts were finding lack of standard process in their operations, and that the belts were spending large percentages of their time working with the operations teams to get standard process in place and mechanisms for collecting data, and that the operations teams just were not engaged in owning the process or owning the improvements after the fact. So again, results were not fast or sustained over time. In 1999, they embarked on piloting a structured methodology that used basic quality tools. After several months of applying it, they saw that they had something that could be implemented with the operations teams, and thought that this was something that they could take and expand broadly across the whole organization. However, it was dependent on a small number of resources at the corporate level to deploy it, and they knew that that was not sustainable, that if they were going to actively deploy it across hundreds of assets at more than 20 facilities, that they needed more resources engaged, and therefore it needed to be a more common, defined methodology for deployment. So in October of 1999, a design team was chartered to develop this common team-based variability reduction methodology that could be deployed across hundreds of assets at more than 20 facilities over the next year. Their goal was to have this implemented across the organization by the end of 2000. They defined a methodology as a structured set of tools, metrics, processes, and practices to drive results in one or more parts of the business. The design team consisted of resources that had been involved in the initial pilots, supervisors, operators, engineers, and a couple of consultants, including myself. The intent of the variability reduction methodology was to squeeze the variability out of the process by working with the operations teams to institute a standard process, identifying and eliminating sources of variability that were within their control, and then work with them to establish the daily disciplines that were necessary to sustain those improvements over time, So if they needed to be then at a new level of performance, that they could use Six Sigma to take that step change. And you can see that presented here in this graphic where the variability looked pre-variability reduction implementation, much like process A. Variation and reduction then squeezed that variability out of the process, got some standardization and stabilization in process, and allowed them then, if that new level of performance was not acceptable, to take it to a new level of performance using Six Sigma and other more advanced tool sets. The desired benefits were that the teams would be engaged in improving and sustaining their own process performance, that they did not have to depend on external resources to do that for them, but that they could be engaged in doing that on a daily basis. And to standardize and stabilize the process that could yield fast and efficient results. They also wanted to do this in a way that would minimize capital expenses and risk, and to lower the noise in the processes so that they could use more complex methods of understanding sources of variation, such as Six Sigma, to create breakthrough improvements in the process, to take that step change in the performance. There was a 12-week structured roadmap that used data-based problem solving to squeeze the variability out of the process. That roadmap was designed to align with the Six Sigma DMAIC model. The first week involved developing a capable team, training them and developing them into a solid team. Second week, the team defined the standard process and implemented visual management. And that aligned very much with the measure phase. Then in weeks 3 and 4, they implemented that standard process with the rest of their crew members. Weeks 5 to 6, they then took that standard process and focused on eliminating sources of variation that they had missed in their definition of the standard process or were beyond just methods that were maybe materials or equipment related. And then in weeks 7 through 12, they focused on instituting controls to sustain the improvement over time. Now the roadmap was specifically aligned with Six Sigma so that it was not viewed as something that was competing with Six Sigma but was complementary to Six Sigma, and that the teams used the same language and terminology as the green belts and the black belts so that they could work together in making improvements to the processes over time. The tools that were integrated into the roadmap fell into 3 main categories. First, those tools that focused on the team understanding the process and documenting that process. So those included process maps, flowcharts, standard operating procedures, work instructions, visual displays, and workplace organization, or 5S. Second set of tools focused on team communications and communications with their stakeholders. That included an action register and a scorecard. Third set of tools focused on process analysis, and those included check sheets, basic statistics, Pareto charts, fishbones, histogram, run chart, and scatter plot. As you see here, there were just basic statistical tools, nothing complex, things that the teams could do themselves either by hand or using Excel, tools that they already knew and had access to. Now, what other elements might be needed besides a roadmap and a set of tools for success? Well, the design team asked themselves this, and looking at other methodologies and things that had worked for them in the past, as well as some research that they had done with other organizations, identified these additional 7 elements that they incorporated into the methodology. First item that was deemed to be critical was the linkage to the business strategy. Second, roles and responsibilities. Third, performance tracking. Fourth, documentation. Fifth, training. Sixth, coaching and audits. Seventh was recognition. Linkage to the business strategy, opportunities for implementing variation reduction were prioritized based on the savings potential of a given asset, customer demand versus what the current capacity and capability of the asset the team was, availability of resources, and whether or not other initiatives were impacting the process. This process of prioritizing the opportunities was led by the continuous improvement director for each business unit. Roles and responsibilities were defined as well. The manufacturing vice president for the business unit was identified as the variation reduction sponsor. The department manager, the press room manager, or the binding manager, or the customer service manager were identified as the champions. Team leader for the individual effort was one of the process supervisors. In most cases, these were multi-shift operations, and so there were multiple supervisors, and one of them would be selected to be the team leader for this effort. And the team was a cross-functional group of folks from the process that ran the equipment and or supported the equipment. That may be maintenance, engineering, human resources, and or IT resources, including the members of the team that ran the equipment. Each team was also assigned a Six Sigma green belt that could be their data analyst to support them in analyzing the data. Performance tracking was another key element. Now, one of the nice things here was that there was one single key metric across all manufacturing assets, and that was run rate. Or for the transactional processes that later deployed variation reduction, it was cycle time or defects. This common key metric allowed for very defined roadmap and checklists for implementation. It also allowed for sharing across the organization of best practices and learnings. Visual displays were erected within the first couple weeks of implementation in the process. These were usually whiteboards that were attached to the equipment or on a wall next to the equipment, and they included run chart of the performance, the run rate or the cycle time or the defect rate, Paretos of those things that were the biggest sources of delays or issues in the process. They had a thermometer that showed where they were in the implementation of variation reduction, and they also posted their action register so that this could all be visible to everyone on the team at all times, as well as anyone that supported them or anyone that walked in and out of the area. Over time, these displays were also automated into scorecards that were developed with the assistance of IT resources that could then easily be accessed to inform senior leadership of the status. So this information then could be shared across and up and down the organization. Almost anyone and anywhere else in the organization could see what performance each team was obtaining. The combination of the definition of roles and this performance tracking led to what Jim Collins in his book Good to Great led the leaders to create a climate where truth is heard, where they could lead with questions. They could ask about the data and the patterns that they were seeing, not come with answers. They could also engage in dialogue with the operations teams and conduct autopsies or focus the teams on getting to root cause without pointing fingers or blaming people or parts of the process. It also allowed them to build mechanisms that turned information into information that they could not ignore and that they could really focus on improvement. The process also included quite a bit of documentation in order to be deployable across multiple assets at more than 20 facilities. Standard documentation was critical. And this included an implementation guide, which was affectionately called the field guide. That guide included the roadmap, the tools in detail, roles and responsibilities in detail, information about the audit process, about the requirements for certification, examples of best practices, things that had worked, things that had not worked for other teams, as well as frequently asked questions. There was also an intranet site for sharing best practices and success stories that was implemented through Lotus Notes. Training was another key element that was done at the champion level and the team level. Champion training was a half-day focused on the basics of variability reduction and the role of the champion in supporting the team. The champions were taught the roadmap and the basics of each of the tools so that they knew how to ask the right questions and support the team and break down barriers for the team. The team, however, focused two and a half days of training, and 2 of those days focused on the roadmap and the tools so that they knew what to do when and how to use each of the tools. They also had a half day that was focused on team chartering, team building, and project management. So they left at the end of the training with a plan for what they were going to do the next week. This training was conducted by a certified variation reduction trainer that was at the plant site. This was a local resource, not a corporate resource or an external consultant. Another key element was coaching and audits. Audits were integrated into the roadmap at 4-week intervals. These audits were conducted by a second party, someone outside the plant site, appointed by the continuous improvement director of the business unit, at least initially. Over time, however, it's got to be quite a challenge for the directors to manage as more and more teams were implementing variation reduction. And so the assignment and scheduling of audits was centralized by a corporate team. You might ask, well, why is coaching and audits such a key piece of this methodology? It was used to assess the team progress and to provide firm, honest feedback to the team and the champion. It was also a means of sustaining momentum and gains throughout the roadmap and then afterwards, as the audits continued after the 12 weeks were complete. Teams knew that someone would be coming in every 4 weeks to look at their progress, and that they couldn't go too long just spinning their wheels, that someone was going to come in and give them firm, honest feedback, that they needed to keep making progress. It was also used as a way to coach the team and the champion on their next steps, and used to determine recognition. There were 2 levels of recognition. The first level was called silver certification, and this was granted to teams that demonstrated effective application of variation reduction at the completion of the 12-week roadmap. They had to demonstrate knowledge of the tools and the roadmap, and that they had squeezed variation out of the process. Gold certification was granted to those teams that demonstrated sustained improvement of at least 15% in their primary metric for a minimum of 90 days after silver certification. So this got at the discipline of sustaining the improvement over time. This might all make a little bit more sense with an example. A binding line. Variation reduction was initiated in mid-2000. The team, after training, created flowcharts of line startup and operation and analyzed it for non-value-added activities and the different practices between shifts and individuals. They then agreed to a standard process for startup and operation of the line, documented that standard process in work instructions, and they used those instructions to train all the operators across all shifts. The team also worked with IT to define categories of downtime that negatively impacted line performance and incorporated them into a recently automated downtime report that was then used to create a delay Pareto. The Pareto after 30 days looked like this. The top reason for delays was something called high book jams, and this became the initial focus of the team. 8 of the remaining 9 delays were what's called missing signatures, and this was viewed as a more systemic issue that perhaps that was beyond the capability and the tool set that the team had, and it was assigned to a black belt as a project. A signature is actually when a book or a magazine is printed, multiple pages are typically included on one plate or one cylinder, and that resulting printed sheet of paper has, with the multiple pages on it, is folded, and that resulting folded sheet of paper is called a signature. And those signatures are what are collated to form the book or the magazine. So if you're missing one at multiple locations around the binding line, then you're missing multiple pages in a book or a magazine. And most customers would be unhappy about that. So you don't want to have those things happen too much. Those things are happening quite frequently, as you see in this process. The interesting thing here was that before they had the automated data collection on the line, these were things that happened so quickly that they couldn't see them or capture them in a manual mode. So the automated data collection that they put in place as a result of implementing their ERP system allowed them to see these things and to be able to track them and to make an impact in improving the situation. So an example of integrating it with IT. The variation reduction team first created a fishbone diagram for the high book jams, brainstormed possible reasons for those book jams and put them on the fishbone, then conducted multi-voting to narrow that down to a few that they could investigate and focus in on. The in-feed trough received the highest vote count. Upon investigation, the team found that the trough was worn unevenly, and this was due to its design. In working with maintenance and engineering, they were able to make a new trough out of stainless steel that not only eliminated the issue, the present issue, but eliminated future wear concerns. The second item on their voting, not jugging the signature, was actually a training issue, so they went back and revisited their work instructions, modified them to reflect the needed steps on how to do that and when to do that, and retrained all the crew on doing that. They also worked with their black belt to identify critical inputs for the missing signatures, and an item that was identified as potentially having a significant impact was the vacuum drop at the sucker cup that picked up the signatures and put them in the stack for binding. There was presently no way to measure that on the binding line. So the black belt and the team working with maintenance and engineering developed some new gauges to measure and control the drop. They experimented with using the gauge over time to determine the optimum range at which the vacuum needed to be, and then implemented control methods for the team to use on a daily basis to monitor the vacuum drop at the sucker cup at each of the packers for picking up the signatures. These methods were found to be very successful, and so much so that they were transferred to other lines at that same facility and then to other plants. After 30 more days of implementation, the resulting delay Pareto now looked like this. You can see big drop. All the bars are much lower than they were before. Now we still have some high book jams and 2 missing signatures in the list, but they've dropped significantly. We squeezed that variability out, but still room for improvement. Another example, implementation of VR across the organization. It was applied over the course of the 4 years that I worked with the organization to over 600 process teams in manufacturing, customer service, finance, and logistics. Variability was reduced 2 to 15%, and average performance improved 4 to 15% as well. One of the functions, prepress, which is the process that converts digital documents into formats required for creating a printing plate or etching the cylinder in the gravure printing process, applied variation reduction, and over the course of their implementation they saw a 40% reduction in cycle time, error rates reduced 70 to 80%, and 25% reduction in rework, and over $300,000 annual savings in reduced spoilages. This also enabled them to accept $700,000 of work from a new customer. So this not only had savings potential, but had the opportunity to help them generate new revenue. Now there were multiple lessons that were learned and incorporated into the methodology over time. First of all, one of the big learnings, people were a little skeptical at first whether this could be done in 12 weeks. And over time, the roadmap and the tool set was found to allow most teams to successfully implement variation reduction in 12 to 20 weeks. And the longer times were predominantly in those processes outside of manufacturing. The transactional processes such as customer service and logistics tended to take longer in that not all their processes ran every day. And usually they did not have access to data, didn't have the automated data that manufacturing had. So this took longer for them to deal with. So the second bullet here highlights that although the original roadmap and toolset methodology was developed for manufacturing, it was found to work quite well in non-manufacturing processes as well, such as customer service, finance, and logistics. Over time, the language and examples in the training materials and in the implementation guide were modified to be more user-friendly for these audiences. Another key lesson learned was that process supervisors have often not had the training in team building, conflict resolution, or team dynamics necessary to lead such a team-based effort, and often require additional training and coaching to serve in this kind of role. When variation reduction was initially implemented, most of these supervisors did not have such training, but over time, corporate HR developed training for supervisors that included team building, conflict resolution, team dynamics. And it was later required that process supervisors that became VR team leads have attended this training prior to serving in this role. It was also found that VR trainers needed the equivalent of Greenbelt training to be able to train and coach teams on the database tools beyond what was in the training. They simply didn't have the experience or the confidence to be able to really train and coach the teams on the database tools that they really hadn't used themselves. But with the Greenbelt certification, they had demonstrated experience applying it themselves. So this helped provide them with the confidence and the experience that they needed to assist the teams. Teams also need the discipline to perform root cause analysis versus jumping to solution. Root cause analysis was not previously in the culture of the organization, so this was a culture change. And through the supervisors, with the additional training that they received and the VR training with the trainers as well and the audits, they were able to drive in the discipline to get to root cause versus just jumping to some solution. Additional lessons learned was consistent audit protocols were needed to ensure consistency from audit to audit and auditor to auditor. Originally, since these were being done on a business unit by business unit level and one or multiple people were involved, there was some complaints of inconsistency from audit to audit and auditor to auditor. But over time, as the audits and the coaching was centralized and scheduled and planned on a central basis, common standard checklists could be developed and were used to train the auditors. The auditors were also trained to use coaching practices versus auditing. So they weren't auditing against compliance against a standard, but their main focus was to coach, to figure out where the teams were and then to coach them through the next steps versus compliance auditing. Since several facilities within the organization were pursuing ISO 9000, they had implemented a document compliance management system. And those facilities that were using such a system found benefits in using that system, and that it provided a mechanism for document management and control. It also provided a way for them to track their training and audit records, and this freed the team from having to do these types of administrative tasks. And over time, those facilities, those sites that were not pursuing ISO and not using such a system, asked to use it as well because they saw the benefits beyond ISO. Benefits of variation reduction were, number one, that operations teams owned the daily process improvement and were much more inclined to sustain the improvements over time. They took ownership for their process and its performance. Capital expenditures for the improvements were minimal. Conformance to schedule improved significantly with the reduction in variability. Customer service was able to commit to new work within a specified period of time with more confidence, and this aided in their relationships with their customers. Operations team members and leadership also experienced less stress in their daily lives. This was something that really was not expected and was not part of the original discussions, but something that was found. I remember visiting a facility in Ohio in the summer of 2000, and they were getting ready to implement another round of training, and there were teams that were just clamoring to be a part of the VR effort. And I questioned about why everybody was so excited and wanting to be a part of this. And the leadership conventional wisdom was that they wanted to get the financial benefits of recognition. But when you went out and you talked to the teams, what they wanted was what their peers had on the lines that had implemented this, which was less stress, less firefighting, less stress, and the knowledge that they didn't have to work weekends to make up for issues during the week. This was a 3-shift operation 5 days a week, and when they didn't meet their schedule during the week, then they had to work the weekends. And sometimes they wouldn't know if they had to work the weekends until Thursday or Friday, so this put a great deal of stress on individuals. And they saw that the teams that implemented VR were not experiencing this, and they wanted it for themselves as well. Additional benefits, the facilities that were implementing and seeking ISO 9001 registration were seeing their activities integrated into the daily work in those areas where VR was implemented. The documentation, the standard operating procedures, the work instructions, the training, the audits. They also saw increased efficiency of Six Sigma resources, which we'll talk about in some more detail in a minute. Also found that the elements of the methodology, the 7 elements, applied to other improvement approaches that they were applying, including Six Sigma, 5S, Quick Changeover, and ISO 9001, and began to expand these things into other parts of their continuous improvement approach. Over 4 years of implementation, they observed a 4 to 10% increase in sustained throughput of their manufacturing assets. There were many financial benefits as well. Those press teams that received gold certifications saved an average of over $57,000 a year. and the binding lines over an average of over $73,000 a year in labor costs alone. They also saw reductions in paper, ink, utilities, and waste. The average savings for a black belt project also increased from $258,000 to $299,000. Now you might say, well, that's only an increase of $41,000. But when you consider that they had over 70 black belts completing 2 projects per year, this had the potential to generate approximately $5.6 million in additional savings a year. So no peanuts. Pretty significant. So I challenge you to ask, how is this different from your improvement efforts? How can you take some of these learnings and apply them to your workplace? And what would be the challenges that you would face? If you'd like more information, an article on VR was published and appeared in the 2012 special issue of Quality Engineering. You see the specifics there as well as the title, or feel free to contact me at the email or phone number listed. Joel, what questions do we have?
We don't have any up at the moment, actually, so if anyone has any questions they'd like to ask, please go ahead and use the questions dialog or chat dialog. And while we wait to see if anybody has any questions, thank you again for presenting today, Susan. I know it's a popular talk at conference, and hopefully is well received here today.
My pleasure.
Oh, thank you. We'll be posting this on YouTube as well, so it will be open for others to see as soon as we can get that posted. And for everyone on the call, you'll be able to access that on the ASQ Stat Division's YouTube channel within the next day. We'll also have, if anybody has questions after the fact or anything, you'll be receiving a follow-up email that will also let you know about receiving recertification units from attending today's